Hello all. So in the last class we had actually discussed about module 1, the introductory part, and also the module 1 was completed. So in this video we actually discuss about module 2 in environmental studies. However, so this is the part 1 of module 2. So that is advances in energy systems. So what are the advances that has been done from the prehistoric era that we will come to see over here. So till now, or in the ancestry part, or our ancestors mainly used sun as a source, and fire was the major leap. After that it was the rockets. After that, in the past 100 years or so, much of advancements haven't been actually done. So let us see where the world will go. So we will just come back to the syllabus part, and we will see what are the advances in the energy system. So ultimate source of energy are sun, moon and earth. So they have energy in them, they have core. So we take energy from sun, it is called as solar energy. As simple as that. So the rapidly expanding human population, human energy needs to be or are increasing rapidly. So as the population grows, we need more and more energy, and we have limited amount of resources, right? So like other natural resources, energy resources are also renewable and non-renewable. So you know which are those renewable and non-renewable. So types of energy sources. So just to refresh your mind, so renewable means they can't be replaced. I'm sorry, non-renewable means they can't be replaced. Renewable means they can be replaced or regenerated or rejuvenated. So some of the non-renewable energy sources are fossil fuels. So that is just example: coal, lignite, crude oil, natural gas, nuclear energy, uranium, thorium, and other used in friction reaction, right? So there is something called as half-life, there is radiation, and these uranium, there is fusion of nucleus and they will give some energy output. Okay, it's kind of deeper into the syllabus, so we will not get into that. Okay, so renewable energy resources, solar energy. So what does it have mainly? What do we use? That is electromagnetic radiation from sun. Wind energy from moving air. Hydropower, it is the energy from falling water, that is nothing but kinetic energy. Tidal energy, energy associated with rise and fall of water. Right. So tides are mainly created due to the gravitational push and pull of the gravitational push and pull because of the earth and moon, right? So next, geothermal energy, the heat from underground steam. So we have the core, the earth, it is very hot inside, but on the upper layer it's cool, we have to be thankful, so on and so forth. So biogas energy, biomass energy and biogas, so which is coming from the waste, that is mainly the methane gas. So different sources of energy, what we actually get: oil, it is 33%, coal 22%, natural gas 21%, nuclear power 6%, that's very less, but still there are so many of disadvantages with the nuclear power, so let's limit into that. Biomass or biogas 11%, hydropower, geothermal, solar and wind, so 7%, that's all. See those, so oil, coal, all those things non-renewable, we are mainly depending on that itself, and India especially is very lagging, it's lagging behind in conservation of energy and also usage of energy in terms of these, that is the oil and coal. We actually import it from other countries, we are not self-sufficient as of now, right? So in total non-renewable energy, we are using 82%, renewable 18%. So classifications of the sources, that is the energy sources. Conventional sources, these are the one which are used in common by all of us. Example, fuels, electricity, etc. Non-conventional sources, these are energy resources which are not used in common. So we can't see it everywhere we go. There are no, you know, wind, what do we say that? Uh, Tidal winds. I'm sorry. I forgot the name. Okay, we'll come back to it later. So we can't. Okay, we'll take the next example. That is, we can't see dams everywhere, right? We can't see geothermal power everywhere. We can't see tidal energy everywhere, right? So in the same way, but fuels, that is petrol, diesel, we can see it everywhere, right? So we will get deep into this hydroelectric power. Right, so electricity produced from water power is known as hydroelectric energy. As simple as that, the energy of falling water captured and converted to mechanical energy by water wheel, that is nothing but turbine, powered the start of industrial revolution. Okay, it is a good thing and a bad thing, industrial revolution, whatever happened. So next, large scale hydropower. In case of high dam is built across a large river to create a reservoir. Water is allowed to flow through the huge pipes laid along the steep hill slopes and controlled at rates that thus spinning turbines. So they are also called as the prime movers and in turn generates producing electricity. Small hydropowers in case of low dam with no reservoir, right, or only a small one is built across small stream and water used to spin turbine to produce electricity. So even smaller than dams, it is called as bunds. Okay, it is called as bund, bunds. Approximately 1/4 of world's electricity is produced by hydropower, so that's a good thing. Next, in India, the generation of hydroelectricity has been emphasized right from the beginning of first 5-year plan. Right, so those were the agendas in the first 5-year plan. By the end of fourth plan, India was able to generate 6.9 thousand megawatts of hydroelectricity, contributing to 42% total power generation capacity. That is huge. So that is good thing. But due to increasing demand, by the end of 8th plan, it fell down by 25% only. So the population growth is very high in India, so that has to be controlled first. But that is the problem which we have been facing, and in turn indirectly it is affecting into the electricity production also. So include use of hydroelectric generator. So construction of dam is essential. Flowing water in rivers and streams are used. Usage of turbines is involved in hydroelectric power in case or in the scenario of India. So this is one of the very nice example of a dam. As you can see, it is a curved dam, and as you can see, the resultant force whatever is acting at the water, the pipe, the gates are in the center of the dam, and as you can see, it is curved. The weight or bearing capacity of the dam is very much more. If you remember the resultant force, sine theta, cos theta in the elements of civil engineering, this again it is applied over here. If you want to see the curved dam in India, you can go to Idukki Dam in Kerala. It is very beautiful, but you can't take pictures inside. So this is a GIF. Yeah, it is called as GIF, not GIF. So this is a GIF where you can see what is happening over here. That is the how does a hydroelectric power plant mainly works. There is a kinetic energy, there is intake, there is a penstock, that is the pipeline type of thing, there is a turbine which rotates, and due to that we get power to the generator and to the powerhouse, and that power is shifted to other areas through the transmission lines. So next source of energy, it is nuclear power. Nuclear energy is non-renewable source of energy which is released during fission or disintegration or fusion, that is union of selected radioactive materials, right? So nuclear power appears to be the only hope of large scale energy requirements when fossil fuels are exhausted. But nuclear energy again has so much of, you know, disadvantages. If something goes wrong, there is a huge, you know, a threat to the society. So you can also watch Chernobyl. It's a very nice mini series which is available in HBO, or you can also download through torrents, I guess. So you watch that. It is a 5 episodes, series. It's a very good, knowledgeable and entertaining kind of series. You can watch it. In the context of nuclear power itself, I am saying, I am not saying don't study, binge watch. Right. So the major advantage is that even small quantities can produce enormous amount of energy. Very small quantity is enough to produce a very large amount of energy. And also there is something called as half-life. So up till certain point it will degrade to a certain extent. After its half-life it will degrade slower. So it goes up till thousands and thousands of years once the fission or fusion reaction has been started. So we can take an example. A ton of uranium of 235 can produce energy equivalent to 5 million tons of coal, right? So 235 tons can actually have an energy equivalent up to 5 million tons of coal. So nuclear energy has been successfully used in generation of electricity in spaceships, marine vessels, chemical and food processing industry, right? So nuclear power plant is there in Kaiga. You can once visit if possible. In nuclear fission, the nucleus of a certain isotopes with large mass numbers split into nuclei of nearly equal mass with release of enormous energy on bombarding by neutrons. So I have a figure of that, what actually happens. So there are certain isotopes which are having large mass. Okay, when they are bombarded with each other, they will collapse, or they will start to blast, and that reaction, it will cause some energy to release. That energy will be taken up. So in nuclear fusion, two isotopes of lighter elements are forced at high temperature until they form a heavier nucleus, releasing enormous heat. That is, two light elements. See that this reaction, it happens so rapidly we can't actually see that. But two isotopes, I hope you know what is isotopes. So they are combined with each other and made into a larger material. So because of that collision, it will give a higher amount of heat or energy, right? So uranium, thorium and plutonium are the major sources. So nuclear power, this is a beautiful picture of a nuclear power plant. So as you can see over here, as you can see these, that is the, these are the cooling towers, right? So whatever this gas kind of thing which is going on over here, it is not smoke, it is not polluting anything, right? Because of the heat generated, the cooling of the towers has to be done. At that time we get enormous amount of water vapor. So this is all the water vapors, this is not pollution. Okay, please keep in mind, this is not gas, this is not a harmful product, this is just water vapor which is going in. This is completely harmless. So this is how it is. So neutron, there is a target nucleus. So as you can see over here, the white one is the neutron, and as you can see there is a fusion product. One neutron, it is hitting the target and it goes out like an arrow, and because of that you can see over here there is a suppression in the target nucleus, as you can see over here, right? Because of this hitting we get energy, right? Next, this is fusion. As you can see, these are the light elements, that is helium, and as you can see over here one more tritium. So you get, I'm sorry, tritium and deuterium, that is, they both will collide with each other. It is forcefully done, and when two things are combined it is called as fusion, and because of the fusion we get heat or energy, as simple as that. So mainly in India they are situated in Kalpakam, that is in Tamil Nadu, Kaiga in Karnataka, Tarapur in Maharashtra, Bark in Mumbai, Narora in UP, and Manuguru, okay, not Mangaluru, so Manuguru in Andhra. So hazards, what are the hazards? If you feel the lecture is boring, you please watch the Chernobyl season, you will get all the hazards actually. Okay, so uranium mining causes radioactive pollution. Health hazards for mine workers, nuclear materials live in surrounding for many centuries. So they are called as the nuclear tubes, right? They are called as the nuclear cells. Once we are done with those nuclear cells, they have to be cooled down, right? So when they have to be, they are radioactive elements for start. So they are very radioactive, and we the people, we can't live with such radiation. And in moon and all, the radioactive energy coming from the sun is kind of 500 times more than earth, it seems. I had just 2 days ago I had read it in the news. So we are not actually capable of sustaining such radioactivity. So they have to be handled very very carefully, and they have to be cooled down, and they have to be maintained. There is so much of maintenance. So as you can see on earth, the radiation effect is spreading. The black part, whatever you can see, that is the radiation effect. How much ever quality control has been going on, it's not enough. There should be much more. So nuclear radiations, what actually happens? So as you can see in the figure, so red one, it is high sensitivity, moderate sensitivity, and low sensitivity. So gallbladder, kidneys, and bone, it doesn't affect much, but your brain, your lungs, your stomach, right, all those things will affect very very highly. Those are the key elements to survive, and those itself, if it gets affected, it's too bad, right? So also because of the nuclear energy or production of nuclear nuclear energy itself, so people have created bombs. So it is one of the early example of nuclear bombs. It was called as Little Boy. Next, coming to one more renewable energy, that is wind power. Wind power is the use of airflow through wind turbines to mechanically power generator for electric purpose. So water, tides, wind, it flows. So it just goes on, right? It goes on continuously until and unless earth is spinning, these things will also be there, right? So without water we are using it wind to generate, or yeah, to generate electricity, that's all, same thing. Next, wind power is an alternative to burning fossil fuels, is plentiful. So wind is plentiful, renewable, widely distributed. It is clean, produces no greenhouse gas emission during operation, consumes no water, and uses little land. The net effect on the environment are far less problematic, right? So energy is developed from the turbine, which creates electricity as the wind turns the blades of windmill. Right, wind farms consist of many individual wind turbines which are connected to electric power transmission network. The potential wind power of our country is approximately 20,000 megawatt, and we are generating about 1020 megawatt only. So there is a scoop. Let us not see everything negatively. Let us see that there is a scope. So largest wind farm is located in Kanyakumari, generating 380 megawatt of electricity. So how do you convert wind into electricity? As you can see, wind turbines convert the kinetic energy wind into mechanical power. This mechanical power can be used for specific tasks, right? So a wind turbine works the opposite of a fan. Instead of using electricity to make the wind, like a fan, wind turbines use wind to make electricity, right? The energy in the wind turns 2 to 3 propeller like blades around a rotor. The rotor is connected to main shaft, which spins a generator to create electricity. Wind turbines are mounted on a tower to capture the most energy. So this is the shaft, this is the main shaft over here, and these blades are called as propellers. So as you can see, this is the very near figure of I always forget this name. Windmill, yes, right. I'm sorry. So this is the very, even that time I had forgotten the name windmill. Okay, very pathetic. Fine. So this is the very closer picture of windmill. So as you can see, these are the fixed blades. We also have emergency brake, hydraulic unit, chassis. This is just for your information. You can see this. So how does a wind turbine work? Wind turbine operate on a simple principle. What is that? The energy in the wind turns the propeller like blades around a rotor, right? As you can see over here, this is the rotor, these are the blades, pitch, right? This is the tower. So you can just pause the video for once and you can go through this: blades, rotor, pick, brake, everything is named properly. So the energy in the wind turns the propeller like blades around a rotor. The pitch of the blades makes optimum use of the wind direction. The wind rotor is connected to main drive shaft, which spins a generator to create electricity. Wind turbines are mounted on a tower to capture the most energy at 30 meters or above. They can take advantage of faster and less turbulent wind. If there is turbulence, the efficiency of the wind energy will be less. So that is not feasible, or that is not economical. So where the turbulence is low, in the higher ground or in the higher altitudes, right? So wind turbines can be used to produce electricity for a single home or a building, or they can be connected to an electricity grid for more widespread electricity distribution. So again, this is just for your information. So onshore and offshore wind turbines or windmills, right? So a regular onshore turbine lasts for about 20 years, and offshore wind turbine is stronger than a onshore turbine. It lasts around 25 to 30 years, produces more than 50% more energy than onshore turbine. But onshore is having cheaper foundation, right? But offshore, when a strong wind blows, it produces around 3 to 5 million watts per megawatts per energy, megawatts per hour. Onshore, cheaper integration with electrical grid network, but in offshore, higher and more constant wind speed. So trade-offs, so mainly it is about trade-offs means what do we get, what do we lose, advantages and disadvantages. Let us see. Moderate to high net energy, but it needs steady winds. It has high efficiency, but backup system needed when winds are low. So again we are giving energy. Moderate capital cost, but we have to use high land. Low electricity cost and very low environmental impact, but there is a visual pollution. Okay, so sometimes when you go somewhere it would look good, but if you're staying then and there itself, it would look very bad, the windmills, right? But again, advantages: no CO2 emission, quick in construction, easily expandable, can be located at sea. But in the disadvantage, again, noise when located near populated areas because of the turning of propellers, right? And also interfere in the birds or migration of birds, and many birds are killed at the time of generation of wind energy. Fine, let's go to next, that is the tidal energy. So ocean tides are produced by gravitational forces of sun and moon, right? So there is an attraction force between sun and moon, so because of that we get tides, so that we can go to beaches like Tanir Bavi, or many other beaches are there in Mangalore. I can't remember it as of now, I don't know why. So tidal power or tidal energy is a form of hydropower that converts the energy obtained from tides into useful forms of power, mainly electricity. So tidal energy is an alternative energy that can also be classed as renewable energy. That is because you might have seen Panampur beach and all. So even Suratkul beach, or wherever the tides are always coming in. So we can see that it is a renewable source of energy. As Earth uses gravitational force of both moon and the sun every day to move vast quantities of water around the ocean, producing tides, right? So although not yet widely used, tidal energy has potential for future electricity generation. As of now it is not used as such because it has to be laid in the tides or in the deep ocean. So humans are not very advanced to take maximum efficiency out of that. So tides are more predictable than wind, so that is a good thing. So since the position of the earth and the moon with respect to the sun changes throughout the year, we can utilize the potential energy of water contained in the daily movement of rising and falling sea level to generate the electricity, right? The generation of electricity from tides is similar in many ways to hydroelectric generation. So the difference this time is that water flows in and out of the turbine in both the direction instead of just one forward direction. A difference in several meters is required between the height of high tide and low tide to spin the turbines. I will show the picture or a GIF so that you can understand it even easily. So this first I will show you the picture. So as you can see, 1, 2 and 3. So 1, the water moves in out past the turbine as tides ebb and flow. Next, turbines turn generator module producing electricity. Third, electricity is returned by underwater cables for use ashore. That's all. So it's a very easy one, right? So there is always tides and there can be energy throughout. So this is one of the better picture. So as you can see, there is a turbine house, there is air in, air out. An example of this type of device is found Isle of Islay in Scotland's west coast. So as you can see, there is, you know, tides, and because of that tides, as you can see, the whole thing will be filled with water and the turbines will move. So what are the advantages? Tidal energy is a renewable energy resource because of the energy it produced is free and clean, as no fuel is needed and no waste byproducts are produced. Tidal energy has the potential to produce a great deal of free and green energy. Low visual impact, as tidal turbines are mainly or if not totally submerged beneath the water. So we want the tides to be moving vigorously so that there will be spinning of the turbine. So next, low voice pollution, as any sound generated is transmitted through water. High predictability, as high and low tides can be predicted years in advance, unlike wind. Okay, we will come to the disadvantages also. Tidal energy is not always a constant energy source, as it depends on the strength and flow of tides. So we want tides to be vigorous, so it will not be always as such. Tidal energy requires a suitable site where the tides and tidal streams are consistently strong. So must be able to withstand forces of nature, resulting in high capital construction and maintenance cost. As you know, it is seawater. Seawater has salts. Salts will cause corrosion. So there is high maintenance. So it also gives danger to fish and other sea life, as they are stuck in the barrage or sucked through the tidal turbine blades. So animals will get hurt, and when fishes migrate from one place to another place, they usually get confused. So next, kind of renewable energy or energy, we can take it as electromagnetic radiation. And electromagnetic radiation is energy in the form of wave due to the changing electric and magnetic fields, right? From where is it coming from? Electromagnetic radiation? Sun. Next, there are different forms of electromagnetic radiation, each with different wavelengths. Cosmic rays, gamma rays, X-rays and ultraviolet radiation are known as ionizing radiation because they have energy to knock electrons from atoms and change them positively charged ions. So they are very, very, dangerous to human beings if exposed in a very high uh, very high time or certain time, right? But as of now, we have ozone layer, which is, and also the atmosphere, which is protecting the earth from harmful radiations of sun. The resulting highly reactive electrons and ions can disturb living cells, interfere with the body processing and cause many types of sickness, including various cancers. The radiation is also caused by the phones what you are using as of now. Also, I am also using the phone. So don't sleep with the phone, even if you are sleeping or keeping an alarm at the time of in the phone and you want to wake up in the morning. Keep it in the flight mode so that there is no signals coming in right? So that you will not have any disturbance or there is no radiation. Keep it in the flight mode and you can technically you can sleep with the uh, you know phone by your side, right? So the other forms of electromagnetic radiation do not contain enough energy to form ions and are known as non-ionizing radiation. The visible light that can be detected by our eyes is in form of non-ionizing radiation, that is the sun. That is not ionizing, so it is not hurting us. So that occupies only a small portion of the full range of spectrum of different types of electromagnetic radiation. So as you can see, sun, high energy, so it has short wavelength so that it can penetrate through any material, but low energy that has long wavelengths, they are non-ionizing radiation. So ionizing radiations are cosmic rays, gamma rays, x-rays, UV waves, that is far UV waves, near UV waves. So the arrow whichever I have given, that is where we can see, our human eye can see. So after that, non-ionizing, that is near infrared waves, far infrared waves, microwaves, TV waves and radio waves. Right, you can hear Radio Mirchi or whatever, Red FM because of the radio waves, TV waves. Now it is all dish, but before that it was with the antennas. Microwaves to cook the food. Infrared waves, that is which is used in the remote controls of TVs. Fine, next we will go to non-renewable resources, that is fossil fuels. Fossil fuels are energy-rich substances that have formed from the remains of organisms that lived 200 to 500 million years ago. So if you are a paleontologist, you would know about the dinosaurs as of Ross. So during the stage of Earth's evolution, large amount of dead organic matter had collected over millions of years. This matter was buried under layers of sediment and converted by heat and pressure into coal, oil and natural gas. So chemically, fossil fuels largely consist of hydrocarbons, which are compounds of hydrogen and carbon. So what do they have? Hydrogen and carbon. If you didn't know, you know it now. Some fossil fuel also contain smaller quantities of other compounds. After the accumulation, sediments exerted increasing heat and pressure for millions of years on the ancient organisms. Hydrocarbons were formed. Most common among them are petroleum, coal and natural gas. Majority of fossil fuels are being used in transportation, industries, heating and generation of electricity. Crude petroleum is refined into gasoline, so diesel and jet fuel that power the world's transportation system. Coal is mostly used in generation of electricity, that what we call it as thermal power. Natural gas is used for commercial and domestic purpose like heating, air conditioning and as a fuel for stoves and other heating appliances. So next, after fossil fuel, will come to the next point, that is coal. Coal is a solid fuel formed in several stages as buried remains of land plants that lived 300 to 400 million years ago and were subjected to intense heat and pressure. Right, so due to intense heat and pressure got converted into coal over billions of years. So there are three main types: anthracite, bituminous and lignite. So anthracite has 90% carbon, bituminous coal has 85% carbon, lignite has 70% carbon. Right, so transportation and combustion is leading to air pollution. So more the carbon, more the pollution. Purification may lead to again secondary pollution. So there is always byproducts which is going on. So due to that, we skip the purification part too. Right, so when coal is burnt, it produces carbon dioxide, which is responsible for greenhouse effect. So almost 27350 billion metric, that is so much. Okay, tons of known coal deposits occur in our planet, out of which 56% are located in Russia, 28% in USA and Canada. So India has only 5% of world's coal reservoir or reserve, and that too not in a very good quality in term of heat capacity. Sorry for the spelling mistake, it was a typo. West Bengal, Jharkhand, Orissa, Andhra Pradesh, Madhya Pradesh and Maharashtra are the major coal producing states in India. Fine, we will come to next fossil fuel, that is petroleum. Petroleum is naturally occurring yellow to black liquid found in geological formation beneath the earth's surface. It is commonly refined into various types of fuels. Components of petroleum are separated using a technique called as fractional distillation. So with various heat we will get various byproducts. Those byproducts will be in turn taken up. That is fractional distillation. You might have studied in second PU chemistry subject. So separation of liquid mixtures into fractions in differing in boiling points by means of distillation. It consists of hydrocarbons of various molecular weights and other organic compounds. So a fossil fuel, petroleum, is formed when large quantities of dead organisms usually zooplankton and algae are buried underneath sedimentary rock and subjected to both intense heat and pressure. Petroleum has mostly been recovered by oil drilling. It is refined and separated most easily by distillation into a number of consumer products, from gasoline, kerosene to asphalt. So this is a complete slide for fractional distillation. So fractional distillation differs from distillation only, and it separates a mixture into a number of different parts called as fraction. So what does it have mainly? A tall column is fitted above the mixture with several condensers coming out of different heights. So that is what, right? You might get the picture of it. The column is hot at the bottom and cool at the top. Substance with high boiling points condense at the bottom of substance, and with low boiling point condense in the top. They have different boiling points, right? The substance in crude oil can be separated using fractional distillation. The crude oil is evaporated and its vapors allow condense at different temperatures in the fractionating column. Each fraction contains hydrocarbon molecules with smaller number of carbon atoms. As you can see over here, there is a beautiful picture. So the main fractions include refinery gases, gasoline, naphtha, kerosene, diesel oil, fuel oil residue that contains bitumen. These fractions are mainly used as fuels, although they do not have other uses too. Hydrocarbons with small molecules make better fuels than hydrocarbons with large molecules because they are volatile, flow easily and easily ignited. So as you can see the picture over here, so in the bottom it is very hot, so the temperature it will subsequently it will decrease at it as it goes on with the top part of the pipe. So first one is first most heated or having or the byproduct which comes out is fuel oil, fuel for ships, powder stations, power stations. Next, diesel oil, fuel for cars, lorries, buses, kerosene. It is used for aircraft fuel. Naphtha, so it is mainly for making chemicals. Gasoline, fuel for cars. So that's why petrol, it is very pure. It takes much time to condense and form. Next, that is the natural gas. It's a better fossil fuel for use due to its environmental friendly nature and efficiency. So LPG gas, for example, that's it, methane. And natural gas is a mixture of light hydrocarbons including methane, ethane, propane, butane, and pentanes. Okay, natural gas is least pollutant due to its low sulfur content and hence cleanest or clearest source of energy. Even natural gas doesn't have any smell. The smell is added in the LPG companies so that we could come to know that there is a gas leak or there will be a danger to the family, right? So it is used in both domestic and industrial purpose. Natural gas is used as a fuel in thermal plants for generating electricity. As a source of hydrogen gas is fertilizing industry and source of carbon tire industry. So the primary component of natural gas is methane, which is highly flammable, burns easily and emits little air pollution. So your own gas, it doesn't have any pollution, right? Do you cook food and do you cough all the time? No, right? So it's very pure. It's cool. So the total natural gas reserves of the world is about 6 and again 50 billion cubic meters. Out of this, Russia again has 34%, Middle East 18%, North America 17%, Africa and Europe 9% each, and Asia has 6%. In India, gas reserves are found in Tripura, Jaisalmer offshore areas of Bombay and Krishna Godavari Delta. So what are the basic effects of using fossil fuels? First thing is acid rain. You have a whole module on topic of acid rain. So when fossil fuels are buried, sulfur, nitrogen and carbon combine with oxygen to form compounds known as oxide, sulfur oxide, nitrogen oxide, carbon dioxide. You know the drill. So these oxides are, when released into the atmosphere, they react with water, form and result in formation of sulfuric acid, nitric acid, carbonic acid. These acids can harm biological quality of forest, soils, lakes. So they are acids. They are coming out of the top of the clouds. Basically, you might that is horrible actually. If you have seen acid rain, thankfully we haven't seen anywhere in Mangalore area. Right. So next, ash particles. Ash particles are the unburned fuel particles. However, with strict imposition of government regulations to trap these particles. So petrol and natural gas generate less ash particles than coal, diesel and gasoline. So next, let us come to solar energy. The solar energy originates from the thermonuclear fusion reaction taking place in the sun. It is one of the potential non-conventional energy source. So it is not very conventional. Conventional are the fossil fuels, that's all. So earth continuously receives energy from the sun, part of which is absorbed while the remaining is emitted back into the space. Solar energy, being non-polluting and non-depletes, is considered as renewable energy and thus falls into principle of sustainability. So in India, solar photovoltaic systems are being installed by Department of Non-Conventional Energy Resources for lighting, running of TV sets, water pumping, etc. In India, there has been already rising demand for solar photovoltaic cell. So solar energy or solar cells are in high demand. So solar cells are used to convert the impinging solar radiation directly off the method so that no mechanical movement of parts is needed. The sun offers an ideal energy source, unlimited supply. So India is blessed with solar power of 2000 kilowatt hour per square meter per year. So that is huge. The daily sunshine itself will be 5 to 7 kilowatt hour per meter square. It's clean, pollution free, inexpensive, freely available energy resources. The solar energy may be converted into other forms of energy through thermal or photovoltaic conversion routes. So what are the various routes? First one is photovoltaic cells, uses photoreceptive cells to generate electricity. Solar thermal, use of solar panels. Next, solar air heating, solar use for heat involving fresh air. So as you can see here, one of the prime example of solar panel, even Elon Musk has introduced solar panels for renewable energy. So this is an interesting picture. So Sonyo in Japan, it is a company, has constructed an amazing solar collecting building that embodies both clean energy ideal and awesome architectural design strategies, right? So that it can capture most of the sunlight, even for the I don't know what it is called as, the keynote event of Apple, which is happening as of now on September 15th, I guess. They didn't release any iPhone, but that is the Steve Jobs conventional hall, I guess. So it is completely powered by solar energy. So this is an old picture. If I had the photo of Steve Jobs convention hall, I, I could have showed you. You can also see in the internet. So let us come to 2020. Now the company Apple is also using 100% solar energy. So next, this is how it is seen, that is the solar heating, how it is used, right? Not here in Mangalore we want AC, but in Canada and all they want heaters, right? So let us switch the places. So next, advantages of solar energy. Solar energy is free and it is available locally in abundance. Solar energy is pollution free. Systems are easy to install, generate and maintain. System can be specifically designed according to individual requirements. Supply of hot water is instant and uninterrupted. Most of you might have, solar water heater. Even I have. Recurring fuel cost is zero. Once installation is done, it is done. Okay, end of story. So heating 100 liters of water to 60 degrees Celsius by solar system results in an energy saving of 1200 to 1500 units of kilowatts of energy per year. So who doesn't want free things? Everyone wants free, right? So solar, sun, energy from sun is free. Right, so next, some points about energy and India. So let us come to the point of, what is happening in India. So the country has installed capacity over 86,000 megawatt renewable power. For the production of renewable power, India is in second position. So Pavagada Solar Park is a solar park spread over total area of 13,000 acres, right, in Tumkur district, Karnataka itself, right? So you can go through or glide in through the slide. So total investment required to build was 2000 megawatt of capacity was estimated at 14,800 crore. By the end of 2018, the park planned to have total capacity of 2000 megawatt and will be world's biggest solar farm. So that's a proud thing. So this is the picture of it, as you can see over here. And recently I was also watching a video in the Instagram of Abhi and New, that is हम क्या कर सकते हैं, that guy, yeah, फर्क पड़ता है. So even he was saying something about the solar energy, right? Yeah, he had come to the TEDx SJEC also. So yeah, so solar uh, energy resources, it's been going on in India in a very good manner. So coming to the next energy resource, that is biomass, or also called as biogas. So it mainly contains methane, carbon dioxide, hydrogen and nitrogen. So it is produced by anaerobic degradation of animal waste in presence of water. What is anaerobic? The organisms which do not require air or oxygen, or it wants very less amount of oxygen to sustain. That is, sustain means nothing but to produce food and produce and reproduce, right? It is a non-polluting, clean and low-cost fuel which is very useful for rural areas. Usage of kerosene can be stopped at villages. So yield good organic manure. The use of biomass energy has potential to greatly reduce our greenhouse gas emission. So this is clean, this can be done. Biogas plant is there in SJEC behind ladies hostel, right? So you can visit once and go and check out the biogas plant. That's all, only do that. So next, it generates the same amount of carbon dioxide as fossil fuels, but every time a new plant grows, carbon dioxide is actually removed from the atmosphere. So that's a great thing, right? So this is an example of a biogas digester. So there is no cutting of trees, there is no money involved for wood, right? And there is no pollution of gas. As you can see over here, the three figures, that is what it means, right? So the waste coming from the toilets, coming from cow dung, coming from kitchen, coming from the farmland, everything, it can produce methane gas, or everything it can give energy. So in SJEC, in St. Joseph Engineering College, Mangaluru, your college, obviously you know, right? So we also have constructed a biogas plant. All the waste which is coming from the kitchens and rooms of ladies hostel, it is, yeah, mainly from the kitchen waste, it is used as a fuel for the production of biogas. The yield, it is used for, cooking, not cooking, it is for the heating of water and also for heating up of milk, right? It has to be heated, right? Milk has to be heated so that food can be given to the students. So this is how a typical biogas plant would look like. I didn't include the picture of biogas plant in SJEC. You can also check out once you are there in the campus, right? So this is the last slide. So National Energy Conservation Day, it is celebrated on December 24th, right? So that's all for today. Next lesson will be on same module but part 2. Okay, thank you so much.